Good morning. I am Sundari, Computer Science Department Assistant Professor. My qualification is MSc MPhil Set Qualified. Today I am going to explain about the finite automata which is used in the compiler design. What are the topics I am going to discuss means about finite automata, types of finite automata. Here two types of finite automata is available. First one is a deterministic finite automata and then non-deterministic finite automata. Definition, transition diagram and then transition table and where it is applied, all also I am going to explain. About finite automata, what is finite automata means? It is a just a machine only, it is an abstract model or machine of the computer. How we do in the computer? In the computer also we can give the any input, after that it process the accepted input and finally it produces the output. Same like this particular finite automata also accepts the input and finally it produces some output. Okay. Then this particular finite automata is also contains a set of several different states. That is a state is a finite one. So that is also finite automata. So what is finite automata means? It is a abstract model or machine of the computer. Then types of finite automata means here deterministic finite automata and then non-deterministic finite automata. Likewise two types available. What is deterministic finite automata means? Already you know finite automata means it is a several different states are available. In that states final state is available and then start state is available. In between how it is traversed means by accepting the states only. So deterministic finite automata accepts first only one input. Each state accepts only one input only. After accepting the input then it goes to the next state. But in the non-deterministic finite automata, it accepts a state, each state accepts a multiple input. We cannot able to determine which input it accepts. Likewise, so non-deterministic finite automata accepts a multiple inputs. So types of finite automata, deterministic finite automata and the non-deterministic finite automata. How it is described means, these are called as a tuples. Okay, so deterministic finite automata described by the machine, M indicates the machine which contains the Q, sigma, delta, Q0, F. What is Q means? It is a finite set of states. Okay, it is a deterministic finite system, so finite set of states are available. Sigma which indicates the input, that may be anything, that may be either character, numbers or anything it involves. After the delta, delta is a transition function. After accepting the input, after performing the transition function only it goes to the another state. So for that purpose here transition function is important. In the DFA, how the transition function is performed means Q into sigma we can get the another state, that is a Q. That particular Q is also available in the input state. After that Q0 is the initial. In here we are having the Q0, that is the initial state, F is the final state. So DFA how it is described means by using the set of tuples. So 5 different tuples are available: Q, sigma, delta, Q0, F. Okay. So non-deterministic finite automata. So in that particular non-deterministic finite automata, how the tuples are used means the same tuples only: Q, sigma, delta, Q0, F. Q is a finite set of states. Here sigma, here only the variation is occur, that is a non-empty finite set of symbols are available. It does not accept any empty symbols. Delta, here Q is delta is a transition function. In that particular transition function, Q into sigma we are having the 2 power Q states are available. After that here as usual in the DFA, what is the role of the Q0? The same role is played in the DFA, NFA also. So Q0 is the initial state, F is the final state. Okay. So deterministic finite automata, non-deterministic finite automata, how the tuples are used. Okay, the definition. After that transition diagram. Transition diagram which is nothing but a pictorial representation of the states. Already you know several different states are available. Those particular states can reach the finite state. In between it travels the several different intermediate states. How it is represented in a diagrammatic manner. For that purpose, states are represented by the single circle. Okay, the circle states are represented by the single circle. After that in between transition functions applied, you know. So for that purpose here arrow symbol is used. Arrow symbol used for transition function. After that here we are using the double circle. What's the purpose of double circle means? It indicates the final state. Okay. So here one example is available, that is a DFA. By using this particular finite automata, we can able to check whether language, in that language several different strings are available, whether that particular string is present in the language or not. That this particular finite automata can able to tell, okay, that can able to produce the output. For example, here 101, it is also string. Okay, so here 1 is also one element, 0 is also another string, 1 is also another one. Now we are going to construct the DFA to accept this particular string, that is a 101 string. So initially Q0 is a one state, Q1 is also another state, Q2 is also, these are all the intermediate state. Q0 is the initial state, Qn is a final state, in between intermediate states are available. So first here 1, that particular state accepts 1, after accepting it goes to the Q1 state. Another one is a string as a 0. After accepting the 0, the Q1 goes to the Q2. After accepting, Q2 accepts the string 1, then this particular DFA, that's a deterministic finite automata, only accepts the string 101. It is a transition diagram of DFA which accepts the 101 as a string. Okay, so here Q0 is a initial state, and then arrow indicates the transition function. After accepting the after performing the transition function, after accepting the input, one state moves to the another state. Here Q0 is the initial state. In that state accepts the input. After performing the transition function, it goes to the Q1 state. So likewise, finally it reaches the Qn is a final state. It is a transition diagram. The same thing also applied for the NFA also. First we discuss about the how we can able to form the transition table. Here also one table is available. In that particular transition table, we are splitting first column into the two things, that is a state, another one is a input. In the state side, we can represent what are all the various states we created. So Q0, Q1, Q2, Qn, that is represented in the sequential manner. After that, what are all the various inputs we can able to give? Only two strings only, that's a 0 and 1. That is a 2 input only we can able to use. It is for accepting the binary. Okay. Suppose if you are having the any characters means in that time we can use anything, A, B, C or anything. Otherwise we can use the star indicates a multiple. Likewise you can use. It is simple string accepted DFA. Okay, here we can give the in the first column which input. Here 2 input 0 and 1. So 0 and 1. Okay. So in that time Q0 is the initial state. First check whether it is a input. First check whether Q0 accepts 0 or not. Okay, here we should change this one. Q0 is a one state, that particular state after accepting the 1, it goes to the which state? Q1 state. So here we are represented the Q1. For 0 input, it doesn't accept any 0. So in that we can put just dash only. Then now Q0 is over. After that Q1. In that particular Q1, check whether it accepts 0 or 1. It accepts 0 only. So after accepting the 0, where it goes to the Q2 state. So here we can represent the Q2. Next week we should check whether this particular Q1 state accepts 1 or not. It doesn't accept a 1. So in the time we put the dash symbol. So likewise Q2. This particular Q2 only send the input. Q2, after accepting the 1 only, it goes to the final state. So that is only represented. For the 0, as usual, we put the dash symbol. Qn, it doesn't accept any input symbol. So it is a final state. So that is in the dash format. Okay. So DFA is a deterministic finite automata. By using that particular thing, we can check that is a strings also represented in the transition diagram as well as the transition table format. Here non-deterministic finite automata's transition diagram. Here also we are giving the starting state, final state, in between the intermediate states are available, but only one variation. Which variation means states can accept the multiple inputs, but in the DFA each state accepts only one input only. But in that particular non-deterministic finite automata, states can accept more than one input. Here is an example, that is a Q0 is a one state that accepts 0 as well as 1, that can accept the multiple inputs. Okay, here Q0, after accepting the 0 also it goes to the Q0 state only. After accepting the 1, it goes to the Q0 states only. Then after that, if it accepts 0 means it goes to the Q1 state. In that particular Q1 state, it accepts 1 means it goes to the Q1 state, Qn, that is a final state. Its corresponding transition table is this one only. That is here also we split the first column into the state as well as the input. In the state side we sequentially write the Q1, Qn. Then here we can represent the symbols, that is the input symbols, that is a 0 and 1. Here Q0, that particular state, if it accepts 0 means it goes to the Q0 also. After that, the same Q0 states accepting 0, it goes to the Q1 state. So here we represent the two states, Q0 and Q1. Suppose Q0 state, if it accepts 1 means it goes to the Q0 states only. So that is also represented in the Q0 state. Q1 state, it doesn't accept 0. So in that time we put the dash symbol. If it accepts 1 means it reaches the final state. So here I mentioned the Qn. Okay, it is in the final state. In the final state, it doesn't accept input as well as the 0 as well as the 1. So that is represented in the dash symbol. Okay. These are the transition diagram, transition table. Finally, applications we are going to discuss. DFA, where it is applied, DFA means language recognition and then compiler design, network protocols and then cyber security. In all fields, the DFAs are used. What about NFA means it implements the regular expressions and then natural language processing and then hardware design and search engine also NFA is used. With this, I conclude the video. Thank you.